We're now going to start looking at surface area, and we're going to begin by looking at prisms because prisms are the kind of building blocks of solids. All prisms are polyhedrons with two congruent parallel faces, and the other faces are called lateral faces, and those lateral faces in a prism will be rectangles. So a prism is something that's just joined up with rectangles. So here I have a hexagonal prism. I know that because I have a hexagon as my two bases, and it's a prism because all of the lateral faces are rectangles and they're joining the two prisms to make a so that they're parallel. We call these faces the lateral faces and these two faces the bases. Now, prisms can be right or oblique. We name a prism according to the shape of its base and whether it is right or oblique. A right prism will sit basically straight up and down. The height will be the same measurement as its lateral edge here. So this is a picture of a right rectagonal prism. Now, if these were squares, we could give it an even more special name. We could call it a cube. A cube is a type of prism. Over here we have an oblique triangular prism. It's oblique because the height of this prism is not the same measurement as the length of the lateral edge. Notice the bases are still parallel. It's still a prism, it's just an oblique prism. The height of your prism must always be perpendicular to the base. In a right prism, your height will be the lateral edge of the prism. We like those because they're a whole lot easier. The surface area of the prism is the sum of the faces of the prism. Here, in our prisms, we have two bases and we have a lateral area. The lateral area is the bit that you could almost wrap off. So here, with my back to my hexagonal prism, we had two bases, which were hexagons, and then we had all of these rectangles that made up the lateral sides. If I were to essentially unwrap it, the lateral area is the area of all of these rectangles put together. Now, if this were a product in a store, this would be the label. The lateral area is equal to the perimeter of the base times the altitude. And the reason we can do that, if you look, these sides here, when I add them all together, would equal the perimeter of that base. So this side here is the perimeter. The altitude is the height of your object. Remember, it has to be 90 degrees to the base. So my lateral area is perimeter of the base times the altitude. So my total surface area is two bases plus the lateral area. So here's some more pictures, just so you can see. Here we have a rectangular prism. They're unfolding it. You can see how A, B, C, and D, they made up the perimeter of the face up here. When it unfolds, you end up with A, B, C, D as the length of the rectangle that is the lateral area, and H is the height. So your surface area is the lateral area plus two bases. So let's do some examples. Remember, I want to find the surface area and the lateral area. I'm pretty much always going to start with the lateral area because I need it to find the surface area. And so your lateral area, ooh, that did not work. Let's try that again. Your lateral area is equal to the perimeter times the height. Here, I can see that I have a height of 4. Now, I don't have all of the sides of this base to get the length of this side, but I can use Pythagorean theorem to figure it out. 4 squared plus 4 squared equals c squared. If I go through and I solve this all the way to the end, and I recommend that you do, you end up getting that c is 4 square root of 2. So this side here is 4 square root of 2. So my perimeter ends up being 4 plus 4 plus 4 square root 2, or if we're going to simplify it, 8 root 2. So the lateral area is the perimeter, 8 root 2, times my height of 4. We know 8 times 4 is 32, and that root 2 is just tagged on the end. And my units will be inches squared because we're still in area. Even though it's three-dimensional, we're still looking at area. Now, if I want to get the surface area, that's equal to the lateral area plus the area of the base times 2. So the area of that base is a triangle. So I'm going to use the area of a triangle to find capital B. 1/2 base times height. That gets me 1/2 of my base is 4. My height is 4. 4 times 4 is 16 divided by 2 is 8. So when I plug in up here, I have 32 square root of 2 for my lateral plus 2 times 8, which gets me 32 root 2 plus 16 as my final answer. Oh, inches squared for the surface area. All right, let's take a look at the next one. This is a regular hexagonal prism. It's hexagonal because we have a hexagon, and I need to find the area of the hexagon and the area of the lateral edge. So let's start off doing your lateral area. Remember, which is perimeter times height. Well, here, my perimeter of my base, we have side lengths of 4, and there are 6 of them. So my perimeter would be 24. So plugging in perimeter times height, 24, my height is 10. I end up with a lateral area of 240. That'd be centimeters squared. Now let's look at the total surface area. Surface area is lateral area plus 2 times the area of the base. Now the area of the base is where we're going to have to spend some time on this problem because that is a regular polygon. And if you look, they give me the side length, but they don't give me the apothem. And if you remember, area of a regular polygon is perimeter times apothem divided by 2. So I'm going to have to take a look at this. I'm going to draw the right triangle that we keep drawing right here. I know that's really poorly done. I'm sorry, guys. Each angle in a hexagon is 120 degrees. So this angle right here must be 60. So that means that, let's just redraw this whole triangle, shall we? Let's make it a little bit easier. Okay, cool. This is a right angle. Oh, come on. Right angle. This would be 60. This up here must be 30. I know that the length from here to here must be 2 because it's half the side length. Now, from our old ratios, we know that this is n, 2n, and n square root of 3. So my apothem must be 2 square root 3. So a equals 2 root 3. We already found that the perimeter was 24. We're ready to plug in. Area equals 24 times 2 root 3 over 2. My 2's cancel, and I end up with 24 square root 3. Now, the surface area is equal to the lateral area. We found that to be 240 plus 2 bases, so 2 times 24 square root 3. So that's equal to 240 plus 48 square root 3. All right, identifying solid figures. We name solid figures. They're either prisms or pyramids or spheres or hemispheres. This one right here we call a pentagonal prism because if you look, the shape of the top is a pentagon. It's a 5-sided figure, and it's a prism because it's 2 parallel faces joined with rectangles. This shape here would be a trapezoidal prism because it's 2 parallel trapezoids joined together with rectangles. Down here, this would be a square prism. Now, I can't just jump and say that it's a cube because I don't know that the lateral edges are also all squares. All I know is that the base is a square. Now, this is not a prism. This is a pyramid, and it's a pyramid because I only have one base, and all of the lateral edges meet at a vertex, a single vertex. We're going to call this a rectangular prism because the base is a rectangle, or a rectangular pyramid. Oh my gosh, I'm sorry guys. Rectangular pyramid because the base is a rectangle and all of the sides join at a point. This would be a square pyramid because the base is a square and it's making a pyramid. And this is exactly what it looks like. It's a cone. So let's talk about cylinders. Cylinders are almost exactly like prisms, except that their bases are now circles. And just like a prism, it can be right or oblique. The height of the cylinder must be drawn perpendicular to the base. And the lateral area, this is like the soup can label. The lateral area is still equal to the perimeter of the base times the height, but when my base is a circle, the perimeter is 2 pi r. That's the circumference, or pi d if you prefer that equation. And again, just like a prism, my surface area is going to equal 2 bases plus the lateral area. But because we know what these are, we can go ahead and write in the equations since we know that the base is a circle. My bases are pi r squared, and there are 2 of them, so 2 times pi r squared for the bases, plus the lateral area. 2 pi r, that's the circumference, times height. Let's do an example. Here they give me a diameter of 6, so the radius must be 3. I want to start off with the lateral area. That's equal to the circumference, it's 2 pi r, times the height. Well, my height is 9, so my lateral area equals 2 pi times 3 for r times 9 for h. 2 times 3 is 6, times 9 is 54 pi for my lateral area. Now let's look at the surface area. Surface area is 2 bases, that's 2 times the area of the base is pi r squared, plus my lateral area. So surface area equals 2 times pi, r is 3 squared, plus, I already found the lateral area of 54 pi. So this becomes 2 times 9 pi plus 54 pi, or 18 pi plus 54 pi, which equals 72 pi. And my units are in meters squared.